Hey everyone, I'm Mr. Hartzler, and I want to talk to you about the structure of axioms and how we kind of use these things. So, first part here is some definitions. Axioms are statements about math that are accepted without any kind of proof. We just believe that these work, and we can't really tell you why. And theorems are statements that we must prove, and proofs start with an axiom and they follow some logical path, right? It's just like telling a really good story, but in math. Let's go and check out some more vocabulary here. Axioms. Let's discuss closure. So closure is just meaning like something actually works and is completed and is kind of closed up and pretty. So if if I add or multiply two whole numbers, then I still get a whole number. So like 1 plus 2 gets me 3, that's still a whole number. 1 times 2 gets me 2, still a whole number. So that means that whole numbers are closed under addition and multiplication. If I can do addition and multiplication to just whole numbers and still get out a whole number, it's closed. A counterexample, or one that's false then, right? This means it's not true for it. If I subtract two whole numbers, so 5 minus 9, then you get -4. But -4 is not a whole number. That means whole numbers is not closed under subtraction. Because it's when I subtract two things, it's not a whole number anymore. Here's a big table of all the things where stuff's closed under. So look at this table. Use this to help you answer your questions, right? Are these things whole numbers? Okay, is it under addition? Good. Subtraction? Nope, doesn't work. And it does for multiplication, not for division. That's because like 1 divided by 2, I know it's kind of hard to see. 1 divided by 2, not a whole number anymore. Same thing that's true with integers. It's closed under everything except division. And real numbers, closed under everything. It's kind of neat that way. Now here's some properties. You've probably heard this before though. Reflexive. Reflexive makes me think of like a mirror. It's reflective, right? So A equals A. Just makes sense. You look in a mirror, you still see yourself. It's reflexive, or it's reflecting your own image. So it's exactly the same. Same on the left and on the right. So that's reflexive. Symmetric property. Well, A equals B or B equals A. That's the same thing then, right? If I say A equals B, and I could also then say B equals A, not a problem. Transitive property. So that just means if A equals B and B equals C, well, then A must also equal C, right? I can kind of swap these two things out a little bit. A equals B, but I know B equals C. Well, that just means A equals C then, not a problem. That's transitive. Then we have some properties of addition. So these things are addition properties. Commutative, or I can commute them. I can move them around back and forth. A plus B or B plus A, I can commute that A around. And then associative. That's the one where I start to get my little parentheses in here, and it doesn't matter what order I group them in. So I can have A plus and then B plus C, right? I have to do the parentheses first. Or I could add A and B, then add C. Doesn't matter how I do that, it's all fine. Identity. That just means whatever you do to it, it stays the same, right? I have my identity, and no matter what happens to me, that identity pretty much stays the same. So if I add 0 to it, I don't get changed. I stay A. And my additive inverse. Inverse is like opposite. It undoes all of the other stuff. So what undoes an A? Well, that's minus A. If I combine my first thing and then the thing that undoes that, I get 0. And then we have multiplication properties too. So the commutative, A times B or B times A, it's the same thing as the last one. I just shuffle all those things about. It's nice. Then the associative property, same as with addition. I just can move my parentheses around in different places. So associative, think about parentheses. Identity, it doesn't change it. What can I multiply to an A to not change A? 1. I can multiply anything I want by a 1, doesn't get changed. Multiplicative inverse, it's a fun word, right? Multiplicative inverse. So it's undoes, right? That's what inverse is. It's like the opposite. It undoes multiplication. Well, that's going to be division. But I show that like a little fraction here. So I multiply by the inverse of A, the multiplicative inverse, so it's 1 over A. Ooh, that shouldn't be 0 though. Multiplying those two things gets me a 1. And that's because this. My multiplicative inverse multiplied to my original piece here is going to get me a 1 because that's my multiplicative identity. And then we have the distributive property, or just FOIL, right? I send this A over to everything inside my parentheses. You've seen that before, and you just get that stuff out. And then my 0, if I multiply anything by 0, it becomes 0. Even 0, right? 0 times 0 is still 0. And that's it. That's all I got for you, folks. Have a great rest of your day, and don't do drugs.